going to present some of the work that we've been doing in the past 4 years, trying to understand the DMT experience, both from a neuroscientific perspective and a phenomenological perspective, and the intersection between both of them. So I'm going to allow myself an extremely introductory slide, which is the idea that these substances have been around for a while. Archaeological evidence points to maybe thousands of years. Maybe some of this archaeological evidence is debatable, but we certainly have very good reasons to think that this has been part of the human story for quite a long time. And if we're interested in the study of consciousness, we have to take these states into account. If there's a model trying to understand consciousness that doesn't include these altered states, these specific serotonergic induced altered states of consciousness, then that theory of consciousness would be incomplete. And that is the backdrop of my story today, basically. How can we understand this from consciousness research perspective, from the scientific view specifically? So what we're trying to do broadly is the mapping of a complex space, of an unknown, uncharted space. Mostly, we can say that because human beings have been exploring this in their own experiences for many years, it has been explored. The advantage of the scientific method is one of discipline. We can try to understand this through a very detailed, rigorous approach that is reproducible and that has a drift over generations, a way of accumulating knowledge that is important, right? So in this charting of this space, we have two big challenges. One concerns phenomenology, or how do we understand experience. This, of course, is very, very challenging when we're thinking about ineffable experiences, experiences that are difficult to communicate, such as those in non-ordinary states of consciousness. And finally, understanding the brain under these states, or the biological effects more broadly as well. The brain is incredibly complex system, as they mentioned, and we have a large amount of challenges. And finally, how can we connect both of these realms, of these ways of understanding the world, right? Through experience and through the material objects that surround us that we can study, namely biology and the brain. So within this framework, we've conducted two studies now. One pilot study. We had 13 participants in which we administered different doses to DMT to each. So we were progressively giving doses of DMT so that we could understand better what would be the response of people under the effects of DMT in the scanner, because, you know, as you might imagine, being in the scanner under DMT is not the ideal scenario to have a DMT experience. But, you know, you have people for everybody, and people very interested in also contributing to the research, so that's great. So we progressively try to characterize the effects. We gave us a small, a medium, and a medium to high or a high dose, which is 20 milligrams of DMT fumarate intravenously. And then we had an imaging phase where we try to understand the effects of DMT through FMRI, which gives us a nice spatial resolution, and EEG at the same time, so the combination of both things. And as you can see, we've also made that scanner look a bit nicer for participants, decorated it a bit. And we had our nice leopard-looking blanket for people to go in. So we gave 2 doses of DMT to 25 participants, medium to a high dose, 20 milligrams. And basically, we captured the experience trying to understand the progression of effects over time. So we collected intensity ratings from 0 to 10 on every passing minutes. So what are some of the interesting things in the phenomenology that we picked up? One is this notion of sense presences or entity encounters that are commonly reported under DMT. We saw that it was significantly reported that people had these encounters, that there was some sort of communication between participants and these presences, and that these experiences could have both a positive and also a negative affective valence or tone, which also could vary within a session. So a person having an encounter which is at the beginning scary and then evolves into something more more loving, more interesting, more caring, or more kind. It's a nice depiction, visual depiction from one of our participants of some of these encounters. And some correlations with EEG activity with these measures, with a strong caveat that this might be a false positive. That's not necessarily what's happening in the brain indexing these activities, but we have some evidence supporting that maybe decreases in beta rhythms have something to do with these entity encounters. And of course, this is inserted in the wider context of sense presences in ayahuasca use in the Amazon. So the idea of encountering entities and communicating with entities is not an isolated, it appears not to be culture dependent kind of like quality of DMT-related experiences, such as the one found in ayahuasca. So ayahuasca has a cosmovision in which entities play a crucial role, right? Another aspect that we've been interested is how the comparative aspects, how other states of consciousness might relate to the DMT state. So the near-death experience is an example of that. We found that many features of near-death like experiences are also found in DMT experiences. And if you look at this little graph to the right, that charted line marks the official scientific consensus for having a near-death experience. And all of our participants in our pilot phase scored above that. Now, this questionnaire has its limitations, and we're working towards refining how can we understand this so that we can really tap into the specificity of the near-death experience phenomenon in relationship to other altered states of consciousness. Right? We've also have some interesting findings on potential therapeutic applications to some degree. These are all healthy participants. What we do find reductions in depression scores in our participants, and as well reductions in neuroticism and trait anxiety. And this, of course, is relevant to current ayahuasca research being performed in Brazil and probably in other places in the world, associated to how maybe ayahuasca, which contains DMT, may be a useful tool to treat major depression. So, why is, from the scientific inquiry on consciousness, interesting to study DMT? Why do we have a specific interest? Well, if we have the notion that conscious experience, how we generate worlds of experience, is in a constant interaction with an environment, if you will, a conversation with the external environment. And we're in a situation in which we are laid on our backs with our eyes closed, ready to get DMT, and this interaction is reduced or mostly eliminated. And then we give DMT and we have worlds of experience. Then we have a very interesting tool to try to understand what are the mechanisms that may underlie the construction of these worlds of experience. And very similarly, in a way, to the dream state. The dream state is a state in which the body is mostly disconnected from the environment. We're not aware of what's going on the outside. Nonetheless, we have a rich world of experience, which could be said that is mostly driven by internal mechanisms. So we have an apparent similarity between the dream state and the DMT state, which is very interesting from the perspective of consciousness research. Why is this interesting? The added value to this is that we can provide this in a controlled environment and we can generate it at will, right? The idea of studying dreams is not that easy because it's not obvious when the person is dreaming. We can have some hints, and it's not that obvious that the intensity of that dream state, of that world that is being generated, has the comparable intensity or even the enhanced intensity of a real actual experience. And in fact, in some of our research, we've seen that this idea of experiencing different worlds, different dimensions or realities is one of the strongest rated items in our questionnaires. Another way that we've tried to approach this is through the administration of DMT and then capturing the temporal progression of subjective effects. So very simple pharmacological paradigm. On every passing minutes after administering the substance, we ask for intensity ratings. And usually people with DMT, in the first couple of minutes, they go up very quickly, and they start having mild effects in perception, which gets, by the second minute, increased. And by the third minute, people are very much in that sort of altered space. And then these progressively fade away around 20 minutes. So we have a very nice tool here to try to understand these mechanisms, induce short-acting effects, and maybe connect experience to brain activity within this time range. What have we seen in terms of EEG activity? In our pilot study, we've seen that, as mentioned by Robin yesterday, this reduction in alpha rhythms. So the main rhythm that we find in the human EEG in electrical activity, especially in the back of the head, is strongly attenuated. This is quite interesting. If you close your eyes, this alpha rhythm goes up in a massive, massive way. People still have their eyes closed. We administer DMT, and we see a massive desynchronization of this rhythm. And this maps out the progression of the intensity of the experience in a very, very nice way, in a highly significant way. So it's just a unique sort of effect, a very nice kind of like finding, a very clean finding if you want. The reductions of this alpha wave follow the trajectory of experience and maybe possibly indexing the richness of the experience that is being evoked, if you will, this engagement with the external reality. If you open your eyes, this alpha rhythm goes down in a normal state of consciousness. So it's basically kind of like the same idea, but following the intensity of the progression of these effects. Similar findings we find with entropy. So this idea that the brain is expanding the possibilities that it may inhabit, the repertoire of brain states may be possibly related to this. We see that it's positively correlated with the intensity of the experience. Here you can see this in the brown line and the purple line. So these are both of the brown line is the entropy, and the purple line is the intensity of the effect. So a nice positive correlation with an interesting kind of lag from the entropy measure. But we find a very significant correlation, as you can see here, at the back of the head. That is particularly significant when you control where you do further signal analysis processing. You see that this is nicely localized in the back of the head, the back of the scalp, where visual information is processed. We also have nice confirmation from blood samples that we took from participants and analyzed the quantities of DMT in the blood over time, and we see that there's also a very nice correlation between these alpha effects and these entropy effects. Strong association between expanded repertoire, possibly of brain states, and DMT levels in the blood. Now, in our FMRI study with our recent participants, we confirm some of these findings. We see these strong reductions in alpha, and some very preliminary work on fMRI findings per se. So how do canonical brain networks, the networks that we know are commonly activated during resting states without DMT, so for example, the default mode network and so on, how do they become more or less connected? And we see a very strong reduction in connectivity within the specific networks. So we see the strongest reduction in the default mode network, which nicely reproduces some of Robin's and the team's earlier work with LSD and psilocybin. And this, default mode network, usually associated to mechanisms that are enhanced when we're not engaged in a task, which could be something like mind wandering, for example, or processes related to self-related processing, thinking about oneself, thinking about others as well. And we can speculate that maybe this relates to ego dissolution, right? Or maybe the fact that the default mode network is indexing some sort of homeostatic mechanism, a stability that the brain achieves over its history that is being massively perturbed. Or we can speculate that it's increased disorder. Basically, that the brain is inhabiting less predictable states. We also find a strong decrease in the posterior opercular network, usually associated to pain perception or bodily sensations more broadly. And we can speculate that the massive sense of disembodiment, usually associated to the DMT state, might be associated to this. And finally, decreases in frontoparietal networks. These networks are commonly active when we are engaged in a task or we have a goal at hand. Is characterized as control networks of sorts. And we can speculate that this might relate to the fact that there's loss of control mechanisms. Now, this is interesting if we're analyzing these networks independently, but when we're trying to understand them en masse, if you will, or how they are integrated between each other, we can speak about the brain maybe being more integrated or more segregated. So the red speaks about when networks are communicating between them or they are less communicating between them, if that kind of makes sense how I'm saying it. And broadly, what we see is that there is increased integration between sensory, so networks that are related to processing of sensory effects, and goal-driven networks like the frontoparietal network. And this is very interesting because in common states of consciousness, in common resting state, these networks are usually at the different ends of the spectrum. They're quite segregated. And what we see is that there's a kind of like increased communication between these networks, which we can speculate again. So what does this mean? Is this an active engagement of sensory effects, right? There's a communion between high-level effects of consciousness and low-level effects of consciousness. This might be one possibility. Then we see that the opposite is happening between sensory networks themselves. So visual networks and auditory networks talk less to each other during the DMT state. And the same happens between the task-driven networks. So we have an interesting scenario that we're trying to make sense. We're trying to make inferential processes. And we may be thinking that these high-level processes are achieving a higher degree of autonomy, maybe possibly related to the fact that the brain is acting with a higher degree of disorder or entropy. So we go back to our mapping with this information at hand. And then we're left with the question, well, all right, we have this brain mechanism. This is interesting. But what does this tell us about experience, right? Is this informative? Is this really informing the richness, the variety of the DMT experience, those sensory effects which are so characteristic that everybody's so interested about this substance? And indeed, in our study, we've had increased amount of variability between these DMT experiences. We find some commonalities. So these are some of the sketches that participants drew during our sessions. And we find that the geometrical aspect is present. Many people report seeing rooms, spaces, and so on. And of course, the entities. And there's also stark color sometimes, maybe achromatic experience, chromatic experience, or a high degree of variability. So with this variability of experience, then we ask the question, well, how does this relate to our brain imaging findings? Are they telling us something of interest? So we take a bit of a step back and we then say, well, maybe we should take this idea of experience a bit more seriously, which of course relates to this notion of the hard problem of consciousness, the idea that there is a missing ingredient in the connection of what it feels like to be in a specific state of consciousness and what we're seeing in our neuroimaging experiments, what's happening at the biological level. So we then take this premise and then, well, maybe we can take this to understand experience in its own right. And once we have a disciplined approach to understanding experience in its own right, then we can try to connect both of these levels. Right? So the idea is that lived experience is where we start from and where all must link back. It's like a guiding thread, right? So another nice quote from the difficulty of studying experience or the idea of phenomenology. Usually DMT experiences are marked by a sense of ineffability that when that is reported back, we tend to grasp on these categorical concepts, trying to understand the experience from these different standpoints. And I think this quote by Jean Piaget is quite illuminating. The knowledge of the interior world is no more given to us than is that of the world of objects. In both cases, we are faced with a construction on the basis of an interaction between the subject and the world, the subject and itself. So this intuitive notion that understanding experience is an easy task, that is something that is given to us, is also a bit of a fallacy. We know, basically the field of phenomenology and introspection in psychology has tried to tackle this challenge with varying degrees of success. And it's still an ongoing endeavor that cognitive neuroscience has mostly abandoned until recently. So with this in mind, we employed a specific interview technique called microphenomenology, which aims to understand experience from a discipline approach. So there's a mediation on how people talk about their experience. They tell their experiences, and they make sense of their experiences. So with this approach in mind, we performed interviews in which on every passing minute that we asked these intensity ratings, we then use these intensity ratings during the interview so that we can trace back the story for every participant. Right? How can we understand the richness of experience, the variety of experience? And this usually helps people remember, and we were able to develop a bit of a story. With this, we were able to characterize the different categories of experience, or invariants of experience, if you will, and we found three main features: a visual experience, a bodily experience, and an emotional and cognitive experience. And we found that there was a progression over time in each of these categories across participants. The nice thing is that then we were able to use this information and trace it back in our pilot study with our EEG results. And we found that the visual imagery, the progression of visual effects, was associated to decreases in alpha, as well as increases in low frequencies and increases in entropy or disorder, which is very much a brain state associated to the state of dreaming. So we have a close resemblance between two different states of consciousness which share phenomenological features, in which our study, through this neurophenomenological method, we were able to detect. So without the constraint of putting experience there to relate this to brain effects, we couldn't have gotten there. Right? So this is the basic idea. Bodily effects associated to reductions in beta. This is a signature usually associated to bodily effects, bodily sensations, and so on. So a very nice kind of like mapping into what we already know in terms of EEG effects and synchronization. And emotional effects more broadly related to increases in entropy or disorder. Possibly, or if we want to speculate, maybe associated to this idea that the brain is inhabiting different possibilities, different brain states. And with this, what we're trying to do as a starting point, as a proof of concept, if you will, is generating constellations of biological measures, and we have a mapping, a combination, or a composite of these states, and the relationship with phenomenology. So a bridging between these two aspects. And with this has allowed us, without this we wouldn't be able to do that, to associate this, the presence of these increases in low frequency, delta and theta waves, which are present in dreaming. And these theta waves, according to a theory by Robin, has been associated to possibly a wide variety of altered states of consciousness, which might be related to this notion of endogenously generating worlds of experience, if you will, such as dreaming, psychedelic imagery, acute psychosis, and temporal lobe epilepsy. Right. So with this in mind, we're trying to understand conscious experience beyond this notion of a simple kind of like bimodal. You have contents of consciousness and then you have arousal, which is the dominant kind of like scientific approach to conscious experience. And instead, we have the idea of global state of consciousness or multidimensional states of consciousness. How can we generate complex mappings of experience beyond 2 dimensions and associate that to brain effects? And with that, we go back into our premise, our starting point, our guiding thread. How can we chart this difficult space to chart, and using experience to try to understand that and linking that to brain activity. And some of the things that we're trying to do now is how can we understand also experience in relationship to certain contexts or certain cultural effects, right? And with this in mind, we've developed some measures related to how these experiences can change our views on metaphysical beliefs, beliefs related to the nature of reality or the nature of consciousness. And we see some interesting findings that we can talk about if we speak about this later, and also changes in beliefs regarding fatalism, free will, and supernatural realms. And yeah, I'd like to acknowledge specifically Robin Card-Harris, my main supervisor, David Nutt, Rob Leach, all of our participants. Specific acknowledgement to all of our participants that participated in the research. Thank you very much, and all of our collaborators as well. And yeah, thank you for paying attention.